Today, I'll show you 4 experiments about static electricity. So these are the materials.
Nightmares creep while you and me repeat. This bittersweet heat is suffocating. I'm waiting and always hesitating. Kryptonite desires set my heart afire. Heart on fire. Set my heart afire. With crimson secrets and forbidden bliss, can't stay still, don't stop that thrill. My bones crave your skin, temptation within, mistakes ignite the silence. Nightmares creep while you and me repeat. This bittersweet heat is suffocating. I'm waiting and always hesitating. Kryptonite desires set my heart afire. Heart on fire. Set my heart afire.
So, what did we observe from the experiment? So, we see that the water bend and the cut pieces of the paper stick to the object that has been rubbed. To understand it better, let us know the structure of the atoms first. You can see that the green sphere and the blue sphere are compressed together. They are called nucleus. The green sphere are called neutron, that is neutrally charged. And the blue sphere is the proton, that is positively charged. The yellow ball, that is free moving and not bind truly, are called electrons, that is negatively charged. These electrons can be plucked away by friction, becoming the other object positively charged because of loss of electrons, and the other is negatively charged with more electrons. So why did the papers stick to the negatively charged object? It is simple. Because like charges repel each other, while unlike charges attract each other. Charges produces electric field. When the charge is negative, the electric field is inward. When the charge is positive, the electric field is outward. When you rub the balloon to the hair, the electrons of the hair transfer to the balloon. That makes the balloon negatively charged and attracts charges like paper and water. We can also get the magnitude of a charge with the use of Coulomb's law, thanks to Sir Charles Augustin de Coulomb. Coulomb's law states that the electrical force between two charged objects is directly proportional to the product of the quantity of charge on the objects and inversely proportional to the square of the separation distance between the two objects. You can see from the formula that F represents electrical force, Q1 and Q2 represents the two quantity charge, and D squared represents the square of the separation distance. And K, also known as Coulomb's law constant, has the value of 9.0 times 10 to the power of 9 Newton meter squared over Coulomb squared, is a proportionality constant in electrostatics equation. It is also called electric force constant or electrostatic constant. It also has a value of 1 over 4 times pi times epsilon naught. That has a value of 8.854 times 10 to the power of negative 12 Newton meter squared over Coulomb squared. We can also get the formula of electric field by combining the mathematically expressed formula of electric field and the formula of Coulomb's law. We can now have the derived formula of electric field, that is, electric field is equals to Coulomb's law constant times quantity charge over distance squared. That is all. I hope you learned something and thank you for watching.